Okay, so we are on day 3 of section 1.1. We're going to start today by looking at different function families. Remember, functions that belong to the same family share key characteristics, and the parent function is just the most basic function in a family. Okay? Functions in the same family are transformations of their parent function. So up until this point, we've talked about 3 different parent functions. The first parent function that we talked about was the constant parent function. Okay, so in the little box, see how there's like a box below the rest of it where it goes through and it says graph, and it's got a graph. And whenever I want to locate the graph that has the horizontal line, and I want you to write in the constant function y equals 1. Okay, so anytime you see a horizontal line, that is your y equals 1 parent function. The next parent function we've talked about is called a linear parent function. A linear parent function is in the form y equals x. So I want you to look at the box and identify where you see a line. Okay? And I want you to put in the function y equals x. This is your linear parent function. It looks like this. The absolute value parent function is the one that we've been working a lot with. Okay, that's where we were doing all the transformation. Absolute value is your v-shaped function. I want you to locate which one looks like a v and write in y equals absolute value of x. Okay, so the one that's the v is y equals absolute value of x. The function we haven't talked about as much is the quadratic parent function. We are going to be working a lot with quadratic equations in chapter 2. So I just want to preview what the shape of the graph looks like. Okay, so if you see a quadratic parent function, it's going to have this nice U shape. See how that's different than the absolute value function, which has the V shape? And they're 2 different functions. Some new vocabulary today is domain and range. Domain is all x values used by the function, and the range is all of the y values used by the function. So if I look at the first function, let's see. If I look at this first function over here, the constant function, I'm going to start with the domain, the x values that are used by that function. I'm going to drag this cursor over to the very left-hand side of my x-axis. Remember, see how my pointer is right here on the x-axis? Okay, and I'm going to click and drag it from left to right along the x-axis. Going left and right, are there any x values that I'm not going to use? No, I'm going to use all of the x values, right? Because it goes infinitely to the left and infinitely to the right. Okay? So my domain is going to be all real numbers since I'm using all of those x values for my function. And I click and rotate this, and I start at the bottom of the y-axis, and I work my way up. Here, I don't see any graph. What is the only y value I see a graph for? When y is 1, right? Above 1, there's no graph, and below 1, there's no graph. There's only a graph when y is exactly 1. That is why the range is that y is 1. Okay? So that's the range of that. Okay, looking at a linear function, you can see from left to right, I'm going to use all of those x values. Okay? Same thing with up and down. If I put my cursor on the bottom of the y-axis and I move my line up and down, you can see again, I'm going to use all of those y values. It goes infinitely in both directions. Okay? We've got all real numbers for our domain and all real numbers for our range. If I go over here to the absolute value function, and I start at the left and I move my cursor from left to right, am I using all of these x values? Yes. Okay? You can see how the arrows point to the left and to the right. I'm using all of those x values in the infinite direction. Okay? All real numbers is your domain because you're using all of your x values. Now if I rotate it this way and I start at the bottom of my y-axis is there any y values being used down here by my function? No, we don't see the graph down here. What's the first time I see the graph? What does y have to be? 0, right? Y has to start at 0 and then be positive in order for my graph to show up, right? Because of that fact, y has to be greater than or equal to 0 for my range. Okay? Remember, range is your y values. Quadratic works the same way for the range. If I look at the y values of my quadratic equation, same deal. Do I see any y values being used by my function down here below the axis? No, there's no graph there. What's my first y value I see? 0, right? And then all of the positive y values. Okay, so that's why my range is y is greater than or equal to 0 for that quadratic parent function. Domain and range is challenging. We're going to talk more about that as we go on throughout the year. But I wanted to introduce it today. Okay, so hopefully you were able to fill this out. This is your linear, oops, let's not do it in yellow. This is your linear parent function, which is y equals x. This one was your constant parent function, and that parent function is y equals 1. This is your absolute value parent function, and that's y equals absolute value of x. And then the u shape is the quadratic parent function, and that is y equals x squared. Okay? So just a recap of different parent functions. You don't have to rewrite those since they're in the box above. Remember, when we're talking about equations, or when we're talking about functions, anything inside the absolute value, or the parentheses is horizontal movement, anything outside absolute value, or parentheses is vertical movement. Right? Inside parentheses, horizontal movement. Outside parentheses or absolute value, vertical movement. Let's keep that in mind. So, we've been working a lot with absolute value equations. Someone remind me, if I have a negative out front, what would that mean? It's going to be a reflection. Yep. If I have a negative out front, that's going to be a vertical reflection. Yep. What about this a value? What's that going to do to my graph? Yeah. Great. It's going to vertically stretch or shrink my graph, right? Vertical stretch or shrink. Okay? Moving inside. Inside is the horizontal movement, outside the vertical movement. You want to go ahead? Great. It's going to be a left or right translation. Okay, so I'll put left, right. And then moving outside, we have plus or minus k. What's that going to do? Oh, and I haven't heard from Logan. Up or down? Great. That's going to be a translation up or down. Okay, so those are the transformations we work with for absolute value. Does everyone see the relationship between absolute value, linear, and quadratic? Look how similar all of those equations look. Really, the only difference is, for absolute value, I see absolute value bars. For linear, I see parentheses. And for quadratic, I see parentheses squared. But everything else looks the same. Okay? So if you see a squared, you're going to use a quadratic parent function. That's the U shape. If you see an absolute value bar, you're going to use the absolute value parent function. That's the V shape. If you see neither the square or the absolute value, then it's got to be linear. Okay? And linear is y equals x parent function. Remember, linear is just a line. Okay? So all the rest of it works the same. So if I look over here at linear, see how this says plus or minus? If that were minus, that would be a vertical reflection. Whatever A is would be your vertical stretch or shrink. Whatever your plus or minus H is would be your left, right. whatever your plus or minus k is would be your up down. Okay, it still works the same way. So in this first example, we're going to state the parent function and the transformations, and we're going to draw a quick sketch. It says label one exact point on your graph. So if it is a V shape, I want just one exact point, the vertex. Whatever the vertex is, I want that for the absolute value. If we're talking about a U shape, whatever the vertex is, that's the exact point I want to know. Whatever linear function you run into, if you have a linear function, I want to know how you're transforming that origin point. And I want to know how that origin changes. Okay, so you're just labeling one exact point and then drawing a quick sketch for the rest. So if I look at this first example, I'll do a couple with you and then I'll let you try a couple on your own. If we look at this first example, does everyone see the absolute value bars? So what do you think the parent function is? Absolute value, right? Y equals the absolute value of x. That's going to be my parent function. It wants to know the shape of that parent function as well. If this is my coordinate plane, the shape is just a V with the vertex at the origin, right? So now I'm going to transform that shape. What do you think the negative out front tells you to do? Do what? Yeah, it's going to switch it. If it's negative, it would be plus. If it would be plus, it would be minus. What's going to happen, though, to the V? It's going to reflect down, right? It's going to, instead of opening up now, my V shape is going to open down. Okay, so my transformation is a vertical reflection over the x-axis. Okay, so all I care about is one exact point. So I'm going to put my one exact point, my vertex, and I'm going to draw a V shape that opens down. And I want you to label one exact point. Okay. Don't make your V really wide or really narrow, because then I'll think you thought there was a stretch or shrink. Okay, just make it a normal width. Okay. All right, going on to the next one. X squared plus 5. See how we see x squared? That's going to be a quadratic parent function. Right? Y equals x squared. And if I'm thinking about what that looks like, on a coordinate plane, you have the vertex of 0, 0, and a U shape. Right? It's a U shape graph. What is the plus 5 going to do there? Audrey, do you have a guess what the plus 5 would do? Move it up 5. Yep, there's no parentheses or anything like that around it. So the transformation is going to be a translation up 5. All I need is one exact point. So I'm going to go 1, 2, 3, 4, 5. Make my new vertex. And oops, that's kind of a crooked U. And draw a U shape there. Again, don't make the U really wide or really skinny unless you think there's a stretch or shrink. Okay, it's just a normal width for the U. All right, let's go over here to this last one. We see x minus 2 quantity squared. Let's see, Tyler, what kind of parent function are we going to use for C?
Quadratic.
Very good, quadratic. We see the squares, right? Anytime we see the squares, quadratic. Y equals x squared. Again, on a coordinate plane, the parent function has a U shape. It's going to have a vertex at 0, 0, and then that nice U curve. So now I've got to transform it. X minus 2 is inside the parentheses. Remember, anything inside parentheses or inside absolute value is horizontal movement. Anything outside parentheses or outside absolute value is vertical movement. So if I know this is horizontal movement, what is happening here? Madeline, do you have a guess?
It's going left.
looks like it's gonna go left too. But yeah, you're exactly right. It's going right too, because remember, horizontal stuff is weird. Horizontal stuff's opposite of what you think. So yes, this is gonna be a translation. Right too. So all I need is one key point. I'm gonna take this origin, this vertex, and I'm gonna move it to the right 2 units. And I'm just making a nice U shape through it. Okay, I want you to try the next 3 on your own. Give me a second to kind of work through the next 3 on your own. All right, so I'm going to go through these really quick. The parent function here for negative x squared is quadratic. As soon as I see the squared, I know that my parent function is going to be y equals x squared. Remember, that has that U shape, right? So the transformation with a negative out front would be a vertical reflection. And it would be over the x-axis. So anytime I'm vertically reflecting something, it's just going to go from opening up to now opening down. Okay, so the vertex is going to stay the same. It's going to open down like this. So this is my point 0, 0 there. For part E, as soon as I see the absolute value bars, I know that my parent function is the absolute value parent function. Absolute value has that V shape, and the -3, since it's outside of the absolute value bars, would be a shift down 3. Okay, so I'm going to draw a V shape that's down 3 units. 1, 2, 3, and it'll look something like this. Okay, if you want to make it a nice normal width, if you make it really skinny, I'll think you did a vertical stretch. If you make it really wide, I'll think you did a vertical shrink. So you want to just make it a nice, normal width. And last but not least, this one's kind of weird. I don't see any squared or absolute value. So what do you think it is? Linear. You got it. Yeah, if you don't see any squared or any absolute value, we're going to use the linear parent function, y equals x. And that, let's see, if we've got our coordinate grid, again, the equation y equals x has the origin plotted and a line that goes through it just with a slope of 1, right? It goes up 1 over 1, up 1 over 1, up 1 over 1. Okay, that's my parent function. So what am I doing to y equals x? What's that -2 mean? It's outside of any, there's no parentheses around it. Yep. It'd be down 2. Great. So I'm going to take this origin point and I'm going to move it down 2. Okay. And it's just going to have a line with a slope of 1 going through it. This would be the point 0, -2. Any questions about that? Okay. So that's just, just some practice, doing a quick sketch, just understanding transformation. You do have several, actually quite a few of those on your homework, just as a quick sketch. I just want one exact point. So let's not pay attention to this side over here today. This highlighted part is the new vocabulary terms, are the new vocabulary terms. We have not talked about horizontal reflections yet. We have not talked about horizontal stretches or horizontal shrinks. We have talked about translations left and right. That's a horizontal movement that we're familiar with. Okay. We also have the new vocabulary terms domain and range, right? We talked about how the domain was the function's x values today, and the range is the function's y values. And I've also been using the term vertex a lot. Vertex is the highest or lowest point on a function. Okay? So these are some new vocabulary terms that we're worrying about today. Remember, anytime we're talking about horizontal movement, what's it going to change, your x or your y? X. Anything horizontal, right, is going to be your x values. Just like the horizontal axis is the x axis. And remember, anything inside those absolute value bars or inside the parentheses indicates a horizontal movement. And horizontal movement is weird, right? Different from what we normally anticipate. Okay, so we're going to start by talking about horizontal stretch or shrink. Remember, anything inside parentheses or inside absolute value bars is weird. It's almost opposite of what we think. So if your D value, or if the number inside the absolute value bars is between 0 and 1, so that means it's something like 1/2, right? That's a number between 0 and 1. It's actually going to stretch out your graph horizontally. Isn't that weird? Right? It's opposite of what you would think. Just like the left-right shift is opposite of what you think. Okay? If D is greater than 1, so let's say D was 2, that's a number bigger than 1. That's going to be a horizontal shrink. That's weird to have a number bigger than 1 and have it shrink. Let's talk about why that is. The best example I can come up with is a heartbeat. Who's seen a heart monitor before? Like, you know, on those shows, it goes beep, beep, right? You've seen that? Okay, so here's my normal heart. Beep, beep, beep. That's my normal heart, okay? Now, I'm going to speed up my heart. I'm going to make my heart go twice as fast. So my heart's like beep, 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 right? Going faster. This is if my heart is going twice as fast. What happened to the distance between the crests of my heartbeat? It horizontally shrunk up, right? If my heart's beating twice as fast, it actually causes those crests to horizontally shrink up. Okay, now I'm going to have a real slow heartbeat. Beep, beep. So obnoxious. Okay, but seriously, when your heart's beating slower, what happens to the distance of the crest? It stretches out, right? When my heart was beating half as fast as what it normally does, it actually caused it to horizontally stretch out. Okay? So even though it sounds opposite of what you would normally think, it actually makes sense when you think about it like a heartbeat. So I put maybe a star on there and put heartbeat on your notes, maybe draw like a cute little heart there. Okay, it'll help you remember it. In my chart, what do I do to the point? Well, it's horizontal, so I know it's going to change my x values. And what I'm going to do is I'm going to multiply my x values by the reciprocal of whatever that D value is. Does everyone know what a reciprocal is? Like if I'm looking for the reciprocal of 1/2, what would it be? 2 over 1, right? I just flip the fraction. That's what a reciprocal is. Okay. The other horizontal terminology that was new was the reflection. A reflection is indicated by a negative inside the parentheses or inside the absolute value bar. Okay, and again, it changes your x values because it's horizontal. You're just going to multiply your x values by -1 to get it to flip. Okay? So here's my general form. You can see it looks the same except for it's got this plus or minus D there now. That's the only thing that's different. So we talked about if D is bigger than 1, that's going to be a horizontal, bless you, a horizontal what? If we've got something like y equals absolute value of 2x, is it a stretch or a shrink? It's opposite of what you think. It's a shrink. Remember, horizontal is weird. It's always opposite of what you think. Okay, so that's going to be a horizontal shrink. Okay, another example might be y equals absolute value of 2 times x plus 1. This would be a left 1 shift and a horizontal shrink. What happens if D is between 0 and 1? Like if I have the absolute value of 1/2 x. It's opposite of what you think. It's going to be a stretch. That's horizontal stretch. Another example might look like this, y equals 1/2, absolute value of 1/2 times x plus 1. That would be a shift left 1 with a horizontal stretch. Yeah.
So what do you want first? Half
It's going to be so like here, this would be a horizontal shrink by 1/2. So you'd multiply by 1/2. Multiply by the reciprocal of what's in here. We're going to do an example like that. Here it would be a horizontal stretch by 2, right? If I flip 1/2, it becomes 2. Okay, so we're going to do an example like that. If d is negative, that's going to be a horizontal what? Anytime you see the negative, Ethan?
The horizontal reflection,
Perfect. Do you know over which axis?
the y-axis.
Perfect. Over the y-axis. Okay, so that would look something like this if you see a negative inside absolute value bars, right? All the horizontal stuff is inside the absolute value. Okay, so let's see an example of this. That looks a little crazy. We're just going to take it one step at a time, chunk it out. Remember, order matters, so I'm moving from left to right. I'm just writing them in the proper steps from left to right. Step 1, we look at this 2. What does the 2 tell me? Stretch by 2. It's outside the absolute value. Anything outside is vertical, it's exactly what you think. Okay? So vertical, oh no, my board just froze up. Go ahead and write vertical stretch by 2. While I try to get a new PowerPoint up. Do, 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 do. I know, I love it. I'm like, it froze. That's not good. Okay, here we go. We're back in business. Okay, so we have a vertical, what did I say? Stretch or shrink? Stretch, right? Outside absolute value is exactly what you think. The vertical stretch by 2. Okay? Now I'm going inside. Remember, anything inside is weird. That's why we lock it inside. It has to stay home. Inside it has the value. It's not allowed out. Ooh, that's kind of messed up, right? If you're weird, you can't leave the house. You gotta stay inside. Okay? Anything inside is weird. It's horizontal movement. So this is going to be what? A horizontal what? Stretch, right? We would think it's a shrink, but it's not. It's a stretch, and it's going to be a stretch by what?
2.
Thank you. The reciprocal of 1/2, which if I flip this fraction, if I flip it, it would be 2 over 1. Okay, it's a horizontal stretch by 2. Put a big note, reciprocal. I'm going to ask you that over and over again. I'm going to be like, what's the key word for horizontal stretch and shrink? And you're going to be like, reciprocal. And I'm going to be like, no. Yes. Okay, so that's a horizontal stretch by 2. Then I've got this thing. It's also inside the absolute value. So I know it's going to be something horizontal. It's a horizontal what? It's a horizontal shift. Which way? Right. Yep. It's a horizontal shift. Right 2. That's what my RT stands for, is right 2. And then the last thing I've got is this -1 out back. That's step 4. What does the -1 do? Alyssa? Okay. What does the -1 do? Shift it down 1. It's vertical shift, right? Down 1. Okay, so there's all of my transformations. I'm going to go in that order when I do it in my chart. Order matters. Okay? So, I'm going to go ahead and in my X and PF column put our parent points. So we have -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. That's for my parent function. And I'm just gonna go in order. Okay, so I'm gonna start with my vertical stretch by 2. I'm gonna start multiplying all my y values by 2. It's y because it's vertical. Anything up and down. Okay, so all my y values, I'm gonna multiply by 2. We get 4, 2, 0, 2, and 4. Okay, that's my vertical stretch by 2. That's step 1. Then I've got to do my horizontal stretch. Horizontal. What is changing? What do you think, Zach? X. Anything horizontal is my x. I'm going to multiply my x values by 2. Right? I use the reciprocal. Don't do the 1/2. You have to multiply by the reciprocal, and that's 2. Okay, so I'm going to take x, and I'm going to multiply all my x values by 2. We get -4, -2, 0, 2, and 4. Okay, that's done. Just one step at a time. Okay. Then we have a horizontal shift right 2. And if it's horizontal, what's changing? X or Y? X. So shift right 2. What am I going to do to my x values? Add 2. Perfect. All right, so let's go over here. I'm building off my x values again. So -4 plus 2 is -2. -2 plus 2 is 0. 0 plus 2 is 2. 2 plus 2 is 4. And 4 plus 2 is 6. All right. My last thing that I have is down 1. Right? That is vertical. Right? Vertical movement is down 1. So I'm going to subtract 1 from all my y values. 4 minus 1 is 3. 2 minus 1 is 1. 0 minus 1 is -1. 2 minus 1 is 1. And 4 minus 1 is 3. And we did all of our transformations. So these are the points that I'm plotting. -2, 3. That's my first point. See how the parentheses go on the outside of the numbers? You use the outermost number in that chart. Okay? Whatever's right next to the parentheses. Okay, then I'm also going to plot 0, 1, etc. All the way down. Let's do that. -2, 3, 0, 1. Someone read them to me. What's the next one? Don't all jump at once.
Come on, y'all.
0, 1. What's the next one? 2, -1. Thank you. And then based on the fact that it's a mirror image, I'm guessing it's going to be 4, 1. And then 6, 3. Okay. Okay. There's my graph. What is the domain of every absolute value function? What x values? What x values am I using here? All of them, right? It's going infinitely left and right. Right? It's going this way and it's going that way. So it's going to be all real numbers. The shortcut for this is a capital R with 2 bars in it. Okay, that's the way to say all real numbers. They don't have to write it out every time. I like shortcuts. And what's the range? Let's go to the very bottom of this graph. Do I see, okay, I'm starting at the bottom of the y-axis. Do I see any y values here? Is there any function? No. What's the first y value that I hit? Does everyone see how it's at -1? The vertex will tell you guys. Like, here's the vertex. See how that's the point? Oops, that's not the point 0, -1. What is that point? 2, -1. See how my first y value is -1? And then what's true? It's either got to be -1 or bigger, right? We either have to have the y value of -1 or it's gotta be bigger than -1. So it's gotta be greater than or equal to -1. The alligator mouth chomps towards the bigger number, right? Y has to be bigger than -1 or equal to -1. Okay, chomp towards bigger. Okay, any questions about that? Now, here y has to be bigger than or equal to -1. What happens if my graph flips upside down? Now it's either got to be the vertex or less than that. Okay, does that make sense? So it's going to depend on if the graph is opening up or opening down. If it's opening up, you have a low point, and everything either has to be equal to that low point or bigger than it. But if the graph opens down, it's equal to that high point or less than it. Okay, so it's going to depend on your graph shape. Okay, I'm going to fly through this one really quick just so you can see an example of a graph that opens down. Okay. Transformation-wise, we can see a negative out front. That's your vertical reflection. What's the 2? I have a 2 inside the absolute value bars. It's horizontal. Is it going to be a stretch or shrink? Opposite of what you think. Good. So it's going to be a horizontal shrink by what? The reciprocal of 2 is 1/2. Good. And then the +1, that's up 1. Right? So in my chart, I've got these points. Oh gosh. -2, 2, -1, 1, 0, 0. Go down. 1, 1, and 2, 2. I'm going to do the vertical reflection first. Okay, so all these signs are going to change. That's done. Then I have a horizontal shrink by half. Horizontal is your x values. Okay, so I'm going to multiply all my x values by that 1/2. Half of 2 is 1. Half of 1 is 1/2. 0 times 1/2 is 0. This is 1/2. Half of 2 is 1. Okay, and then the shift up 1, again, that's vertical movement. That's y values. If I add 1 to all of these, I get -1, 0, 1, 0, -1. Okay, there's my point. I'm going to take a second to plot those. Okay, what's always the domain of an absolute value function? What? All real numbers. That's what x values you're using, is all of them. But look at my range. My y values. If I go to the bottom of the chart, I'm using all of these y values. Am I using the y values up here, though? No. What is the biggest y value I see? 1, right? I've got this point here at 0, 1. So the biggest y value is 1. And then it's got to be either equal to 1 or less than it. So y has to be equal to 1 or less than 1 for the range. Y is the biggest number here. Okay? So I know domain and range can be tricky. That's why I'm introducing it at the beginning of the year. We'll do more practice with it throughout.
Thanks for a great week.